Well, you can see on the screen, this is the first problem relevant to IIT preparation. And the heading of the problem statement is grounded plates. And you can read the statement of the problem as the capacitor plates. I know this thing is called a capacitor. If you don't like capacitors, you can simply call them as parallel metallic plates and nothing else. And the capacitor plates are connected to the ground using galvanometers. That means both the plates are grounded, connected with different galvanometers. Though the job of galvanometer is just sensing the current, it can detect even the smallest current passing through these wires. So role of the galvanometer is limited here. It is just sensing current or charge. So the question is related to what charges will pass through the galvanometers if a charged metal plate is inserted between the plates. That means between these plates, between the capacitor plates. And charge on this plate is Q, and Q is assumed to be 0. This is a positive charge, and this Q is going to distribute it over the surface of this metallic plate. You know why. And suppose if you like to call it the charge Q1 here and Q2 here, then you are going to write it Q1 plus Q2 will be equal to capital Q. This is going to be first equation of yours, Q1 plus Q2 equal to Q. And now the statement of the problem I was reading, its thickness, that means thickness of this metallic plate, is 4 times less than the distance between the plates. That means if the distance between the plates is d, this distance is d by 4. And the next statement is, and the distance from the first plate to the plate, that means metallic plate, is equal to thickness of the plate. That means this thickness is also d by 4, and this is d by 4, and this is d by 4. So this will be simply d by 2. This will be simply d by 2. You can guess all those things here. You can determine these things here. So problem of the statement is gone now. It has been discussed. Now we are going to solve it, and how to solve it is the main problem. I'm going to describe it in detail. And the first thing I can see in this problem is that since the plates are grounded, both are grounded, that means both are at potential of the earth. Since they are connected to the earth, grounded means connected to the earth, and that means they are connected to each other. That means the potential difference between them will be equal to 0. And you can see here is the positive charge and here is the negative charge. So this positive charge Q1 is going to attract charges from earth at the inner side of these plates, and that charge is going to be minus Q1 simply on here, because Q1 can attract only minus Q1 charge from the earth, and this Q2 will attract a minus Q2 charge on the right surface, inner side of the right surface of the plates. And so there will be no charge on the outer sides of the plates. I'm telling you, no charges will appear on the outer sides of the plates. Negative charges will come from the ground to the inner sides of the plates, equal in magnitude and opposite in sign to the charges on the corresponding sides of the plates, sides of the metallic plates. You can see here. And then there will be an electric field from positive to negative charge. If I neglect the edge effect, this electric field here, you can name it as E1, and there will be electric field from Q2 to plus Q2 to minus Q2 in this region, and name it E2. And there will be no potential, no electric field inside the metallic plates. You know that. You know all those things. And the potential difference between these two is equal to 0. Two plates is equal to 0. So from here, this potential is V1 and its potential is V2, so its potential is also equal to V2 because there is no electric field in between, and its potential is V3. You can write here V1 minus V2 plus V2 minus V3. If you move from left to right, you can write here in one more manner, that is since you know this is at higher potential and this is at lower potential, you can write V2 minus V1 is the potential difference in this direction at here between these two surfaces, and between these two surfaces potential difference is V2 minus V3, and this they must be equal to 0. And you can write here V2 minus V1 is simply E1 multiplied by d by 4, because this thickness is d by 4 and electric field in this direction is E1. So you can write V2 minus V1 as E1 plus E1 d by 4, and V2 minus V3 simply you can write here E2 multiplied by d by 2, because this thickness is d by 2, and that is equal to 0. That means you are going to write E1 upon 4 plus E2 divided by 2 is equal to 0. And you know what will be the next thing? You can also write one more line as E1 by 2 plus E2 is equal to 0. That means you got E1 equals minus 2E2. Yes, E1 equals minus 2E2, and like this. So the magnitude of E1 is equal to twice of magnitude of E2. This thing is clear from the statement of the problem. And now if you want, you can always use the idea of electric field lines. You know that the magnitude of electric field is written as number of field lines, that is electric field lines, divided by cross-sectional area at a point. And here the electric field is in this direction, so its cross-sectional area is perpendicular to it, and E2 is this direction and cross-sectional area is perpendicular to it, and both are equal. Both cross-sectional areas are equal. So you can write here that electric field is simply proportional to number of field lines, because both cross-sectional areas are same, and this number of field lines are proportional to, you must know the second statement of electric field lines, that is the electric field lines is proportional to the charge on which these lines begin. That means this electric field begin from charge Q1, and this electric field begin from charge Q2, and you must know the fact about electric field lines that these electric field lines are proportional to the charges on which these lines begin. That means E1 is proportional to Q1, because E1 begins from plus Q1 charges. So E1, magnitude of E1 is proportional to Q1. Since they will be both their magnitudes, I'm discussing their magnitudes, absolute values, and E2 will be proportional to charge Q2. That means you are going to write here Q1, right? Taking under these considerations, taking into consideration these proportionalities, you can write here Q1 is equal to 2Q2. That's right. And you have also one statement, Q1 plus Q2 equals Q. And then using these two equations, you can always find that Q1 is equal to 2Q by 3 and Q2 is equal to Q by 3. You can always find it. So you completed this solution. You can say now that the charge minus 2Q by 3 will pass through galvanometer Q1 to plate 1 from ground, or you can say it in reverse direction, that a charge plus 2q by 3 will pass through plate to the ground, or minus 2q by 3 from ground to the plate 1. And in the similar manner, you can say the charge of minus q by 3 will pass through G2 to plate 2 from the ground. Ground to G2, it is minus. Ground to plate 2, this is minus q by 3. And ground to plate 1, this is minus 2q by 3. And this is okay now. This problem has been solved. So I used the ideas of electric field lines here. The main idea is this. Thank you very much for watching. These kinds of problems can be solved, always solved in this manner.